Here's an exam question on functions. Press pause now and have a go at it on your own first. If you're watching this slide, then hopefully you've tried the question on your own first, but maybe you need some help on how to get started. In question A, we're asked to find the inverse function. So the idea here is set your function equal to y and then rearrange it to get x on its own. So we want to make x the subject of the formula. Remember that when you're rearranging, you need to use inverse operations. So for example, the inverse of add 8 would be take away 8. So can you remember what the inverse of E is? If you've forgotten, maybe have a little look back to your notes from last year. From AS Maths, we're looking for the inverse of the exponential function. In question B, we're looking for the domain of the inverse. Remember that this is the same as the range of the original function. So I would try and find the range of the original function. If you know what the graph looks like, that could be helpful. If not, you could think about substituting minus infinity and then 12 into the function and having to think about what would come out of that function. Hopefully that's been helpful. Press stop now and have another go at this question. On this slide, I'm going to go through the whole question in detail. So let's start with question A. I'm going to set the function equal to y. So y equals e to the 4 minus x over 3 plus 8. And now I need to rearrange it to get x on its own. So first of all, I'm going to move the 8 over. So y take away 8 equals e to the 4 minus x over 3. Next, I'm going to do the opposite of the exponential function, which is a natural log. So the natural log of y minus 8 would equal 4 minus x over 3. Next, I'm going to move that negative x over 3 to the left-hand side, and I'm going to swap it with the log. So that means that x over 3 would equal 4 take away that natural log. Now I need to multiply both sides by 3. You can use a bracket if you want to, or you can actually go ahead and times both sides by 3. The mark scheme looks like this, but it would be absolutely fine if you multiplied by 3 to get 12 minus 3 log y minus 8. Then remember that you need to write down your inverse function answer by changing that log y minus 8 back into x minus 8. So here's my final answer for the inverse function. I'm going to do part B on the next slide. So in question B, we're looking for the domain of the inverse function. This is the same as the range of the original function. If we look at the domain for the original function, we can see that we're allowed to put in anything from minus infinity to 12, and we need to work out what we could get out of that function. So first of all, I'm going to put those numbers into the function. Let's start with 12. F 12. This would be e to the 4 minus 12 over 3 plus 8. 12 over 3 is 4, and 4 take away 4 is 0. So this is the same as e to the 0 plus 8. Now remember that anything to the power of 0 is always 1. 1 plus 8 is 9. Next, I'm going to think about putting minus infinity into the function. First of all, let's have a look at the power. 4 take away minus infinity over 3. This could be considered the same as 4 plus infinity over 3. If you take an infinitely large number and you divide it by 3, it's still infinitely large. If you then add 4 to it, it's still infinitely large. So when we put minus infinity into the function, it would tend towards e to an infinitely large number plus 8, which is an infinitely large number. So the domain of f minus 1, which is the same as this range that I've just found, goes from 9 up to infinity. I like to use the bracket notation for domains and ranges. I find it easiest. I'm going to put a curved bracket on the infinity, as we always do. But the 9 came from substituting in the 12. And if you look back at the 12 in the question, 12 had a square bracket, so 9 will also have a square bracket.